What's going on, everybody, and welcome back to another episode of Untamed Outdoorsmen. Today we are back once again on the Native Watercraft Hammer 12.10 build series, and today we are back with episode 4 of the build series for our friend Carl. So today's episode is the second to last episode in the majority of the episodes. We may do one or two sporadically way down the road, but we have one more after this one. But today is going to be a really big one. And today we are going to be installing the Minn Terrova 24 volt model. So this is a motor, the Minn Terrova as a whole is a motor that has gained a ton of popularity in the last couple years with the rise of the kayak Terrova. This is not the kayak Terrova. This is the regular Terrova in 24 volt. So again, we're going to get more voltage out of this thing, which is usually going to equate to more power. This Terrova is going to be a really, really nice motor for this kayak. The shaft has been cut. We'll get into that in a little while. We'll talk about that in a minute. But the Minn Terrova is going to be a perfect fit for this kayak. I'm really excited for this thing. And what really excites me is we're going to have an opportunity to do some wiring. I absolutely love doing kayak wiring. You guys know this by now. We've done a ton of different motor installs across different kayaks. And in case any of you are curious, I do have a professional background in these type of marine electronics. I have all the necessary ABYC certifications in marine electrical to be able to tackle a project like this safely and professionally. Quick disclaimer though, with that being said, I am a professional marine electrician, but I am not your marine electrician. It is very important to understand that. You are responsible for your own kayak. I can do what I can in this video to make it as professional as I possibly can and give you guys the best and most accurate info. But at the end of the day, it is on you and you are responsible for your own kayak. I am not liable for any damage, failure, or injuries that may happen from following this video. You are responsible for your own kayak. But either way, moving on. We got a lot of different accessories to talk about here. Probably start with the big one here, and this is our battery. So this is a lead time 24 volt 50 amp hour battery. We are dealing with 24 volt now. We're not dealing with 12 volt like we usually do. So we are dealing with slightly more dangerous equipment, slightly more dangerous batteries. So obviously, you know, take everything with some caution. A little bit more painful of a shock if you get hurt. But yeah, 24 volt battery here is going to be a great one for us. Before you power anything or you do anything, put a fresh charge into it with a lithium rated charger. We already did that, so we're good there. So we got a bunch of miscellaneous things here. So we have some 1/4 inch ring terminals, some tinned copper ring terminals, not pure copper, tinned copper. I highly recommend that for moisture heavy environments like kayaks. Tinned copper 5/16 and 1/4 inch ring terminals. We have some cable sleeving here. This is for looks on our power wire on our motor. We have some 1/2 inch heat shrink, a 3-to-1 marine rated adhesive lined heat shrink. This is for our ring terminals and our connectors. We also have some 1 inch heat shrink for some cable management tricks that we'll do later on. We have some 3M dual lock Velcro. This is for a specific reason regarding our breaker setup. We'll get into that later. We have probably our most important part of the installation, and this is our 60 amp marine rated circuit breaker by Blue Sea Systems. So this is a 60 amp breaker. This was the proper recommended size by Minn and following our 125% rule for overcurrent protection. So that's this guy right here. We have a quick release bracket. This is the identical one to the Minn one, but this is an aftermarket part. This is not the Minn quick release, but it is identical for about half the price, and it's no difference in quality. So kind of a neat little thing there. A few more things here we got. We have some Duplex marine rated tinned copper wire. I highly recommend this kind of wire. I've mentioned this a number of times on the channel. We have our Minn heading sensor. We're going to be installing this in the back, actually, away from all of the other power and stuff like that. So that'll be perfect. We have our bow motor mount from Native. This is a very similar mount to mine. I do think they made some very small changes to this one that they didn't have on mine, but it's an identical hammer plate. It works for the hammer and Titan X. So the hammer, Titan X 12.5 and Titan X 10.5. So this will work out really good. So this is what we need to allow the kayak to have the rigidity it needs to survive long term. You can't just install these things straight onto the kayak, so you have to have this plate here to sort of protect that hull long term. You definitely do need that. We have some 18 gauge wiring for our heading sensor to go through the kayak. This is also Duplex marine rated tinned copper, so that's great. We have some fuses for that heading sensor. We have 2 trolling motor plugs from battery tenders. So these are the battery tender plugs. We'll get a little more into why we specifically have 2 of them, but either way, we have them for a very specific reason. So we'll get a little more into that later on in the video as to why we have 2, but this will work. We have our trolling motor remote, and we have our saddle clamps that we used in the last video for the navigation lights. We're going to be using them again here. So I think that's it for the majority of the accessories that we're going to need. If I had to guess, this is going to be very, very similar to our Bonafide PWR Terrova install that we did about a year ago. It's going to be very similar to that. So this will turn out really good. I'm going to be really happy with how this turns out. I know I will. So yeah, let's begin. Okay, so I think you guys can see me good. So the bow motor is the same shape as my Titan X one, but it is a little bit different how it's mounted. It's not identical to the Titan X in terms of mounting. So we have to use these little like threaded inserts here. We have to actually hammer these in to these 4 little holes here. And we're going to use our trusty dusty hammer here, just whatever you got lying around the house, and we're going to give it some constructive persuasion. So let's hammer this guy in. You don't need to go crazy. The hammer is going to do the majority of the work. All right, so that came out pretty great. So awesome. So now we're going to mount this to the kayak. Okay, so sorry, I wasn't recording for a certain part, but we're going to take the medium length screws in the kit, the ones with a little bit of yellow thread locker on them that are already from the factory with that. And we're just going to screw these into these 4 corners here. 1, 2, 3, 4. And then these 4 holes are going to be for our quick release plate. Okay, so that's nice and tight. Came out good. So our quick release actually came with a ton of different bolts. And I think we're going to have the right length bolt already in the kit here, which is great. This is the identical one that we used on Bruce's PWR. So only going to help us here. So we have 4 bolts. Pop in just like that. Nice and easy. So okay, so this is good to go. There we go, not bad. Looks nice and clean over there. So yeah, very fundamentally similar to my kayak. Not too much different at all. So yeah, let's begin the next part of the install. Everybody. So next up in our install of this Minn Kota Terrova, we have to actually mount our other side of the quick release plate to the motor. And this will be pretty simple. We've done this before as well. This is, like I said, the identical one to our PWR build video. So that'd be pretty good. I do have a couple of quick notes to talk about with this motor. So like we said, it was the 24 volt model. This is the 24 volt Terrova. We have an appropriately sized battery for that. My notes are, this comes with a 48-inch shaft from the factory. It's the only way you can get it from Minn Kota as of right now. In the 24 volt is a 48-inch shaft. This is not the kayak Terrova. This is the regular Terrova. So the reason I'm saying all of this is because, like I said, it only comes in a 48-inch shaft. However, this shaft has been cut. So this shaft was cut DIY, and I need to make something abundantly clear. And there's a reason I didn't show that on camera. If you would like to have your shaft cut on your motor, you will need to have it cut by a certified Minn Kota service center. You cannot do it DIY if you want to retain any warranty for the motor. If you decide to cut the shaft DIY, you instantly void the warranty. Do with that information what you will. I know there may be some circumstances that it's fine, maybe some circumstances that it's not. I'm not gonna, make those decisions for you, but I need to make that abundantly clear. So if you want your shaft cut, it has to be professionally cut by nobody other than a Minn Kota service center. if you have it cut in any other manner, DIY by somebody else, it's not a service center from Minn Kota, whatever it may be, this motor's warranty is instantly voided, regardless of the circumstance. There was an understanding of that when this shaft was cut. There's no surprises. So, you know, Carl, the owner of this motor, understands that his warranty is void on this Minn Kota Terrova. There is an understanding there. There's no surprise there at all. So if you decide to do that, just be very, very careful with how you approach doing that, because these motors are not cheap. So please make sure you make the right choice. But I need to make that very, very clear. So now we are going to focus on mounting our quick release bracket to the Minn Kota Terrova. So it is actually pretty easy to mount the quick release bracket to this. So we're just going to undo all of these. I got a number 3 Phillips here. Just going to undo all of these on both sides. One side will come out. The other side will be tied to this cord going up the shaft. So just be mindful of that. Make sure you don't lose the bolts like I almost just did. So now I'm going to gently flip the motor over. Keyword, gently. I'm going to take our quick release. So we have our hardware bag of goodies here. So this little piece here to hold the quick release into the other side of the quick release, got to make sure you put that in your desired side, whatever you prefer. It doesn't have to be one specifically. Okay, I'm just going to take our bolts. Definitely be patient with all of this. You don't have to rush. No reason to be working fast. I'm just using my fingers, getting the nut resting underneath the bolt, and I'm using the screwdriver to tighten it the rest of the way. And then in a minute, we'll grab a wrench and use that as our leverage to really tighten them down. But right now, I'm just getting them started. When you do this, you will be able to get it on for like 3 or 4 threads, and then you'll feel it stop because it hits like the rubber part of the lock nut. So an 11mm wrench. Okay, so I'm going to use a drill just because I'll be here for like 30 minutes. Obviously, be very mindful when using a drill. You guys know this by now. If you've been watching any of the other videos, just be very mindful with it. Just like that. It's all you need. I'm actually going to make that even lighter. You don't need much when it comes to power drill. So this is just for time saving. Just like that. It's all you need. Okay, we're just going to put this back together. Pretty easy. Okay, one side. Okay, not a lightweight motor. I'll admit that. Definitely not a lightweight motor. So in the bag, there is a pin that we need. And that's just going to go right through it. Just like that. So this is, mounting wise, this is good to hit the water. You just deploy the motor so it's out of our way. But yeah, like I said, this motor has been cut. This shaft has been cut. There is obviously a lot of warranty concern with doing that. So make sure you do it the right way if you are going to do it. So next up, we have to work on our power cable here. We're actually going to be doing a small change to this power cable to improve on it a little bit. So we'll begin that right now. Okay. So now that we got the motor physically mounted, it looks pretty great here. Like I said, it looks identical to Bruce's 12-volt Terrova. But now we're going to work on our power cable here and some little tricks and tips that we're going to be doing with this. So in terms of the wire, so the wire here is about 3 to 4 feet of 10 AWG wire. I see this question asked a lot lately on forums, whether it be like Facebook or YouTube, whatever it may be. I see this question get asked a lot. Of this wire, although it's 10 gauge, is capable of safely carrying the current of this motor. Reason being is because the distance of this is very short. The distance of this small little power lead is short. So you can get away with 10 gauge in this situation. When it comes to sizing wire gauge, when going any sort of distance, there are 2 things that you need to consider. The amperage of the motor and the distance from the battery. Those 2 things go hand in hand. You cannot have one without the other when sizing wire. And a great example of that is if you took the amp draw of this motor, so 56 amps, and you put the battery right in front in the bow hatch here, the wire gauge requirement is going to be different as opposed to what it would be in the back of the kayak, even though the amperage of the motor stays the same. So the battery also dictates your wire gauge because that's your distance from the battery and how far your wiring has to go to reach your power source. So in this example, this short little lead here, this 10AWG lead, is safe to carry the amperage of this motor at this distance, at this short distance. But as we go further away, we need a larger wire gauge to accommodate that distance. I see this question asked a lot of, this motor has 10 gauge wire on it, isn't that the weak spot of the system? No, it's not, because the distance of this 10 gauge wire is small enough to where this is not a problem. However, if you were to run 10 gauge all the way to the battery back there, you would have a problem. This wire would not be adequately sized. So that's why we are increasing our wire gauge to go the rest of the way. But for this small distance here, 10 gauge is perfectly fine. Like I said, amp draw of the motor and distance from the battery go hand in hand when sizing wire. We can't have one without the other. What we're going to be doing is we're actually going to be cutting this quite a bit shorter to have a cleaner install straight to the power link plate. We are going to add some cable sleeving. This is not like a protective sleeving. This is just for look's sake. We are going to be replacing our original power leads here with some proper heat shrink rings. These are 10 gauge 1/4 inch rings to accommodate our battery tender plug. I die by the battery tender plug. You guys know this. I love this trolling motor plug. I won't use anything else. So yeah, we're going to begin that right now. Okay, so I'm just going to get a rough mock-up of kind of what I want to do with that. So it doesn't have to be, you know, absolutely perfect, but try to be close within reason. So, okay. I'm just going to peel back this a little bit. You don't have to peel it all the way back, all the way to here. These wires are kind of glued together. So one thing I am going to do, and you do not necessarily have to do this part. This is optional if you're using a heat shrink connector like these. I am going to add some heat shrink on top of that just solely for looks. Again, if you're running a heat shrink ring terminal, this is optional. But if you are not running a heat shrink ring terminal, this is not optional. But if you are running a heat shrink terminal, this is optional. We just have some 3-to-1 marine rated adhesive lined heat shrink here. Gonna strip our wire. This is just a nice Klein heat shrink specific crimper. So it crimps it down with less aggressive teeth while still getting a very good crimp. I'll leave a link in the description for these crimpers if you want them. So give it a good pull test, really pull on it. Like I've said in other videos, you want this to fail now. If it fails now, that's a good thing and you can fix it. If it fails on the water, that's a bad situation. So definitely do it now. All right, so we got two nice and crimped down. I'm gonna grab our heat gun. So funny enough, this heat gun I think is on the way out because it's starting to like sputter a little bit, but we'll see if we can get this install done and then go buy a new one. But okay, so obviously be mindful of where you put your heat gun after you stopped using it because it's going to be very hot and it might damage your kayak, so be careful. But now I'm going to slide our aesthetically pleasing heat shrink over everything. I'm going to heat that up. Okay, so this is good. So now we're going to take our male side of the battery tender plug and we're just going to undo it. That comes out, slides out. Now we're going to take our sleeve here. This has to go on beforehand. So we have our posts on the battery tender, male side of the plug. Now we're just going to undo them with a 10mm wrench. Now there is a nut, a crush washer, and a washer on here, so be mindful of all three. They may want to like fall. Get it as tight as you can get it with a wrench. Don't use power tools or anything, you don't need them. Our little case goes right back over the top. Just tighten it all down. So now I'm going to take our sleeving here. Again, this is not protective. This is just purely aesthetic, nothing more, but it does help the look quite a bit. So now I'm just going to take a couple of zip ties and clean up this area here. We don't need this port coming off of the motor for this install, so I'm just going to tie it with everything else. We're going to take our flush cuts and cut these completely flush at the head of the zip tie. So in case we run our fingers over it or whatever, it's not going to cut up our fingers, which is a super nice little trick that, like I said in the last video, I believe separates good installs from great installs. So the wiring physically on the motor itself is technically done, but obviously we are far from done. So I gotta wire all the rest of our wire going to the battery, and we gotta wire our overcurrent protection. So, okay, so next up we have to actually drill our battery tender plug into this power link plate. Like I said, I'm gonna offset it a little bit to the port side so we can eventually mount our stow and deploy lines. We're gonna begin that right now. We're gonna need an 1 1/8" hole saw and a very tiny drill bit. The really good thing about these battery tender plugs is inside the box they actually give you a template to work with, which is nice. So I'm going to cut that out. I'm going to mount it as far as I can to the side. I'm just going to eyeball it as best I possibly can. So one thing I like about this area of the bow compared to my Titan X is the fact that this power link plate is angled down so you can fit, different size motors, which is nice. I am going to grab our punch and I'm going to put it at a very, very light setting just to nick the plastic a little bit so we can start our drill holes a little bit easier so the drill bit doesn't walk. Just like that. There we go. Perfect. So now I'm going to take our very small drill bit. I think this is only like a 1/16 inch drill bit, so super small. I'm just going to drill our holes. You want to make sure you angle the drill in the direction that the power link plate is going. So in this case, we're at a slight angle. Okay. I'm going to take our hole saw. This is our hole saw here. So this is a 1 1/8 inch hole saw. And we're going to use this on the 2 inner holes that we just drilled. Perfect. Now, you're probably wondering, what do we do with the excess on each corner on the sides here? We are actually going to take a Dremel and cut out that middle section so we have a complete ovular hole. Okay, so I have our Dremel here. Never a bad idea to wear some eye protection when dealing with stuff like this, just because you're dealing with extremely fast moving blades. So if one of those flies up, that'll be an emergency room trip. So always a good idea to wear some eye protection. So I'm just going to cut off our excess sides here just so we have a complete oval. All right, not bad. So I'm going to take our sanding disc and we're going to clean up that hole a little bit. You don't really need eye protection for the sanding part, I guess. Whatever makes you feel safe, do that. Perfect. So for reference, perfect. And the screw holes line up perfectly. So that's great. So now I'm just going to take our screws that we have, and these do not come with the battery tender plug, by the way. These are number 10 3/4 inch stainless screws, tapered screws. I am just going to screw these guys in by hand. Do not want to forget your gasket. All right, so now the female side of the battery tender plug is fully mounted up, ready to go. So now we're actually going to begin our main hull wire. So I'm going to start by actually undoing our power link plate, and we will begin this part of the install. So we're going to talk a little bit about the wire we have here and the wire gauge that we're using. So in terms of wire, the only kind of wire that I recommend inside the hull of a kayak is Duplex marine rated tinned copper wire. So Duplex is this giant white coating that goes over your otherwise normal positive and negative wires. And what this white coating does is protect it from moisture, from water, protects it from the elements, protects it from all of those things, which I highly recommend on the inside of a kayak. You know, kayaks are moisture heavy environments. They're difficult environments for electronics, no doubt. So you want to do everything in your power to make sure that you protect, you know, your investment, and by doing so, you're protecting your motor as well. So that is the only kind of wire that I recommend inside the hull is Duplex coated wire. In terms of the tinned copper, I highly recommend tinned copper. Tinned copper quite literally is pure copper, except the difference with tinned copper is it has a thin layer of tin going over the wire. The reason that they do that is to protect from moisture and corrosion long term. So if you use, you know, pure copper, you know, regular copper wire, it will work, it will power your motor. However, there is zero corrosion resistance in there whatsoever. So you're going to be fighting a never-ending losing battle with corrosion extremely early on to your installation. And I don't recommend pure copper. And I highly recommend tinned copper. That's going to do extremely well against long-term corrosion, which is potentially pretty common on kayaks. So that's a good little trick. And same thing goes for terminals as well. So we have tinned copper ring terminals here, not pure copper. There's no loss in conductivity as well between tinned copper and pure copper. So they're equally as conductive, but with the tinned copper, you get that corrosion protection. So highly recommend that. So the wire gauge, we're going to talk about this as well. So in terms of what the right wire gauge is, the right answer is that there is no right answer. And I've said that a number of times on this channel. The right answer is that there is no right answer, and it varies on a lot of different factors, including your amperage of the motor and your distance from the battery. All of those things do matter, and I highly recommend doing your own research on your particular build and making those judgment calls for yourself. I am not going to tell you what the right wire gauge size is. It is on you to make those safe judgment calls for your vessel. In terms of what I am running, on this kayak, we are going to be running 4 gauge. Now, 4 gauge, I will admit, is a little bit big for this application. However, given our calculations with ABYC certified wire gauge calculators, with our amp draw, our distance from the battery with a 3% voltage drop, I determined that we were technically at 6 gauge, but I made the judgment call to go to 4 gauge just to have that extra blanket of protection. But there is a fine line where oversizing becomes useless. You can slightly oversize wire. There's nothing wrong with doing that. There's actually no harm in slightly oversizing wire. There isn't really much benefit either, but there's no harm in doing it. However, there is no point in heavily oversizing wire. So if I ran like 2 gauge through this, it's not going to do anything. It's not going to protect you from anything. It's not going to prevent anything. It's not doing you any good. So you can slightly oversize wire past the recommended size for the situation, but don't go overly large to the point where it's useless. And obviously, never undersize your wire. So that's my thoughts on that. So the first thing we're going to do is we're going to cut back this duplex, expose our positive and negative wire, attach it to our battery tender plug here, then snake the wire all the way to our battery area in the hull towards the middle back-ish of the kayak. And then we'll continue our wiring there. So yeah, let's begin at the bow power link plate. Okay, so I do have a little bit of cleanliness tips in regards to doing this the right way. And there's a lot of like hack ways to do it, but in my opinion, like I said, we're gonna do things the right way. So in terms of splitting the duplex down the middle, just find the middle and slowly work your razor blade down. Be very, very careful with this because duplex has a tendency to slip and you can easily cut your hand open or your finger open. I've got a permanent scar on my pinky here from doing that. So be very careful with the razor blade. But we're going to go all the way down pretty far. Not like super far, but you know, 4 or 5 inches down. We're going to add some heat shrink. We're going to crimp on our connectors and then we'll be good to set this up. The excess duplex, I'm just going to take our scissors. Going to cut our excess duplex. Again, doesn't have to be rocket science on that because we are actually going to do a little bit of a cleanliness trick here. So my cleanliness trick is I have this 1-inch 3-to-1 marine rated heat shrink here. I'm actually going to cut off a piece. I'm going to take this 1-inch heat shrink. I'm going to slide it over both our positive and negative terminals. And I'm also going to slide it halfway down our duplex. So 50% of the duplex, 50% of our positive and negative wire. And I'm actually going to heat shrink that down. And that's going to make a nice, good looking wire. So I'm going to give that a minute, let that cool, let that harden a little bit, and then we'll do our positive and negative tinned copper ring terminals, and then with some 1/2-inch heat shrink on each of those. That is a mandatory part, the heat shrink on our terminals. This part is technically optional, but this part is mandatory. So I'm going to slide each of our heat shrink pieces on now. This is 1/2-inch 3-to-1 adhesive lined heat shrink. So we have our crimper here. This is a crimper that is rated to do 4 gauge. I only recommend crimpers that are rated for the wire gauge. Don't try to make any other ones work. So I do have something I need to mention as well. There are probably going to be a lot of people out there that are going to tell you that you need to solder these connections. I actually do not recommend soldering on kayaks specifically. Reason being is because of metal fatigue. So soldering is great on applications that don't involve a lot of movement. But with kayaks, you know, there is so much movement on kayaks. Between being on the road, being on a trailer, being on the water, you know, all the vibration and movement that kayaks see, solder does really poorly against movement, vibration, and metal fatigue. So you do not want to solder on kayaks in particular. You know, soldering absolutely has its place in the world, but in this particular application, I actually do not recommend soldering because of all the movement, all the vibration, all the metal fatigue that the solder joints will see. I only really recommend a high quality crimper that is rated for the wire gauge, along with high quality heat shrink. I know people are very adamant on soldering, and if you really do want to solder, do not make it the only form of connection. Crimp and solder, do them together. I don't recommend soldering at all, but I really do not recommend soldering as the only form of connection. That's a really bad idea on kayaks in particular. So just making that clear. So I'm just going to strip our wire. Grab our 4 gauge tinned copper 1/4-inch ring. Get this guy on there. That's perfect. And now I'm going to take our appropriately rated crimper, put it on the 4 gauge mark, and crimp this bad boy down. Perfect. All right, so give that a really good pull test. Really pull on it. Do not be afraid to really yank on it at all. Give it everything you got. Okay, I'm going to slide our heat shrink over it. And I'm going to wait to heat shrink it down because it'll probably end up bleeding over to this guy. So we'll wait a second. Now I'm just going to repeat the exact process we just did on this one. Okay, so again, really good pull test. All good. Again, everything you got on the pull test. I'm going to grab our heat gun again, heat this guy up. Just gonna stuff all of our wire inside the hull. Okay, everybody, so next up, and the thing that we're gonna tackle next on the install is our battery and our overcurrent protection. So the battery that we have here is a lithium iron phosphate battery by LiFePO4. It is a 24 volt, 50 amp hour battery. I will say that lithium iron phosphate battery technology is a rapidly evolving technology. So new sizes of batteries are coming out, you know, more amp hours into smaller packages. The technology is moving incredibly fast. So there may be, you know, a year or two down the road, there may be 100 amp hour, 24 volt sizes in this configuration. A 24 volt, 100 amp hour battery would be like double the size of this, which is not practical for our situation. But like I said, the technology is always evolving, so maybe down the road there will be something like this in a 100 amp hour. I love LiFePO4 batteries. I think that they're the best budget-friendly brand. So next up, we are going to talk about the most important part of this installation, and that is overcurrent protection. I'm going to keep saying this until I stop seeing people do it, but breakers are non-negotiable safety requirements. There is no ifs, ands, or buts about that fact. If you do not install a properly sized and placed overcurrent protection device, you immediately create a dangerous install for you, your gear, and the people around you. So I cannot stress enough the importance of overcurrent protection. You know, the manufacturer is going to tell you the best size breaker to run. And in terms of circuit breaker placement, you want to be within 7 inches of the battery on the positive side. So no more than 7 inches away from the positive post, 7 inches worth of wire. But this breaker we have here is from Blue Sea Systems. This is a 60 amp circuit breaker. But one thing I love about the Blue Sea Systems is that it's completely flat on the bottom, so it's easy to mount things to it. You can mount Velcro, you can mount whatever you want, you can mount any kind of adhesive, and you can actually mount it right on top of the battery like this. And I love that. So that's exactly what we're going to do. We are going to take our 3M dual lock Velcro, mount it right on top of the battery, so that way we have a very short distance from our positive post. So get that breaker nice and close to the battery. I'm a big fan of that. So, like I said, we got our 3M dual lock right here. We have some extra 4-gauge wire. Now we're going to make a very tiny jumper to go from the positive post to the positive breaker. That'll be like an inch long, 5/16 ring on one side, 1/4 inch ring on the other side. So not too bad at all. But yeah, this should be pretty good. Again, stripping and crimping wires just like we did before. So nothing really too crazy. Like I said, I got some 4-gauge wire here. So we're just going to cut this up, make a very small jumper, and we'll be good to go. So again, we're going to make an extremely small jumper, like as small as I could probably make it. Not very long at all, so even that might be a little too long, but we'll try that. It's going to be a 5/16 ring on one side, 1/4 inch ring on the other side, but I'm actually going to flip-flop the directions, so one of them's upside down while the other one is right side up, because the elevation that this breaker is, it's slightly elevated, so I want to have the ring terminal upside down so it curves upward. And then I'm actually going to cover this whole thing in heat shrink when we're done. So, okay. So like we said, give it the good pull test. Yank on it as hard as you possibly can. This is where it's going to get kind of tricky. Very, very tiny. Again, like I said, very, very small jumper, but I'm crisscrossing the leads like that so it sits a little more evenly. Okay, so like I said, really give it your pull test. Do as much as you can to try and yank that out. So we got our 3M dual lock stuck to this side. This stuff is incredibly strong, so once you stick it somewhere, it won't move without serious force, which is awesome. And then it kind of like locks in. It's not like regular Velcro with like a hard and soft side. It's like two really tough sides, which is pretty awesome. So Okay. So this is all good. Raises up. You can still pick it up. So good to go. So one good thing, one really good practice is as we're still going to be working on our battery here, I'm going to trip our breaker. This just protects ourselves from any accidental short circuiting or anything like that, because that'll shock. And on a 24-volt battery, that'll hurt. So definitely want to protect yourself. Nice and tight. All right, let's go put this in the kayak. For our situation, we're actually going to be mounting the battery like this, sideways. And then tighten it down like that, and boom. So we are actually not that far off here, guys. So now what's the plan for in here? So we are actually going to be doing another battery tender plug through this power link plate right here. We still have to run our power off of the battery and the breaker, but we'll do that in a minute. I'm waiting on one part that'll be here tomorrow, so we're going to focus on something else. But in the meantime, so this is what I got right now. Looks really, really clean. I'm really happy with this. So yeah, next up we're going to actually install our heading sensor in the back of the kayak and hooked up to our yak power. So let's do that quick. All right, everybody. So we are going to take a little bit of a minor detour here as I wait for some parts to finish delivering tomorrow. We are going to install our heading sensor to the kayak. So the heading sensor is this white puck that comes with the Minn Kota Terrova that allows us to have spot lock jog on our system. So obviously this is a huge deal for this Minn Kota Terrova. It's a nice little feature, but there are a couple of specific rules that you have to have for this puck to make sure it's installed correctly. So number one, it has to be on a completely flat surface. We're going to mount it in the rear power link plate, so that's going to be a non-issue. And it has to be a certain distance away from high amp draw loads and batteries. So thankfully, we're going to be a pretty good distance away in that rear spot in the back there, so it's going to be no big deal. So what we have to do is we are going to take advantage of our yak power system, and we're going to hook it up on one of the switches there, and we're going to utilize some universal connectors from yak power. These are just the yak power port with your positive and negative terminals, and we're going to hook up some, this is 18 gauge, so much smaller wire, duplex tinned copper wire, and that's going to go all the way to the back. So we retain our waterproof wiring systems, and this is what's going to go from the bow to the stern. This is an extremely light amp draw load. I think it only requires like a 1 amp fuse, which we do have. We will be installing that as well. But again, not a big deal at all. So yeah, let's get this thing wired up. All right, so a few more things here. I have some 18 gauge fuse holders, waterproof fuse holders, some 1 amp fuses, some step down connectors, which are super nice. What we have to do is we are going to strip these a little bit extra because they don't really leave enough space. So these step down connectors are super nice. They're a little bit more pricey, but I think they're worth it for specific situations. So on one side, you have your blue 14-16 gauge connector, and then on the other side, you have a red 18 to 22 gauge connector. So you can go through different sizes of wire a lot easier, which is nice. I do like that a lot. So we're going to mount a fuse holder here. Okay, so now we're going to take our much smaller 18 gauge. We're going to strip this back, put it in the red side. So this is for the fuse to the heading sensor. Again, this is a 1 amp fuse, so it's not much, but it does require a fuse. So definitely important to run one. Okay, so now I'm going to grab our 18 gauge. I'm going to take our 18 gauge here, and I am just going to grab the negative and run it. I am just peeling back the white coating on the duplex, and I'm going to cut the positive at the length of what we currently have, so this inline fuse. I'm going to cut that amount of positive off, so that way the negative lines up evenly, so it's not like bunching up on itself. We have an extra long negative on our duplex side, much smaller on the positive side to connect our inline fuse to. So it'll go right there, and then this will go right here. So just keeps the lengths nice and even, keeps everything clean, keeps everything consistent. Okay, so we got our little thing rigged up here. So in terms of what's going on, so we have our yak power connector here. We have our 2 step-down connectors going from 14 gauge in the power down to 18 gauge. We have our inline fuse, which is going to hold a 1 amp fuse. We have our smaller red butt connectors here. And we have miscellaneous aesthetic-looking heat shrink on here just for look's sake. But we're going to heat down all the connectors now, and then we'll heat down the aesthetically pleasing heat shrink. Okay, so I'm going to hook this up to the stern module of our yak power system. Just adding some dielectric grease to our yak power connections. Like we said, these get pretty crusty after a year or so if you don't do any upkeep on them. So just a proactive thing. Okay, so next up, we are going to grab our fish tape. We have some fish tape here. I'm going to undo the stern power link plate, and I'm going to slide the snake up to the bow area, which would be pretty easy. We'll tape the tag end of our Duplex, our 18 gauge here, onto that, and we'll slide it right through the kayak. So should be pretty easy. I know you can't see me. I'm just taping our wire onto the snake. Does not have to be a lot of tape since this is not very thick wire and we are not making any difficult runs here. So just a tiny bit of tape will do just fine. Just like that. So we are here. I'm just going to pull it the rest of the way through. Get all of our slack out. We do not want a big like loop of wire in here. We don't want a mess of wire. No excess unnecessary wire. We don't need any of it. Yeah, so that's actually a really good point that I want to make. If I were to like bundle all this up and then just have our positive and negative go into the puck, that's actually a wiring safety concern because this is way too long of a wire run than necessary for what we need. So there would actually probably be a voltage drop issue and a resistance issue because we're going way too long. So you don't want any excess wiring. Just as much as you need, give yourself a tiny bit of slack to work with, and that's it. Got to whip out the funky wire stripper for this because the wire is so tiny. Perfect. Okay, so I'm just going to put some heat shrink over all this to protect the wires a little bit better. Now I'm just going to add some silicone. All right, I'm going to give that 24 hours to dry, and then we will begin the next part of our install. We don't have that much more to do. We're getting close to the end here. So yeah, I'm going to call it a night, and we'll come back tomorrow. Okay, everybody, so it is now the next day, and next up, we are now going to be working on the wiring on the battery side of the kayak. So we already got our circuit breaker mounted up, our overcurrent protection, our non-negotiable safety requirement of overcurrent protection. That's all mounted up, ready to go, nice and close to the battery within 7 inches, so it does meet our requirement. Next up, we are going to be running our wiring, our 4-gauge duplex wire, through the kayak, and we're actually going to run it through this power link plate with another battery tender. Now, to answer the question, because I know somebody's thinking it, Connor, why don't you want to run the wire just right through here? The reason being is because we are going for as clean of an install as humanly possible. Carl and I both loved the idea of running a battery tender plug directly through this because this also serves for a quick disconnect if we need to remove the battery for whatever reason, whether it be charging or anything like that. So the ability to have a nice clean install that retains the bucket while also having a nice quick connect right here in case you need it is awesome. Now, you do not have to do that if you do not want to. It has to get to the battery in some manner. However you wish to do that is your choice. But in our situation, we love this idea and we're going to roll with it. So what we're going to do is we're going to run another battery tender. I'm going to angle it to the side a little bit so it kind of makes these turns to these wires easier. And it's just going to go right up to the battery. So pretty easy, pretty straightforward. Not a whole lot to really do with this one. So yeah, should be fun. Let's get after it. So, like I said, we're going to mount up our power link plate. Again, you don't have to do this part if you do not want to. You have a choice. It's your own kayak. Do what you feel is right. But in this instance, I'm going to mount it slightly off to the side because that's where our leads are going to be coming off of, to this side. So perfect. So we got the battery tender plug drilled. I'm just going to undo the power link plate, grab our wires, do our ring terminals and our heat shrink, and then we'll be good to hook the battery tender plug up All right, so again, just repeating the same process that we did earlier in the kayak up at the bow. Again, just be very mindful of your razor blade. This is a very easy way to cut your hand open, so. Again, this big 1-inch heat shrink is technically optional. You do not need to use this if you don't want to. I just really like the look of it. I just think it's a great attention to detail thing if you want to do it. So with the larger ring terminals on this powerlink plate, you definitely want to be mindful of your positioning of the terminals. Try to make them have the most contact. Because if you angle them the wrong way, they won't be able to really bite down on the terminal very well with this giant lip on the powerlink plate. So just be mindful. Okay. Great. Just for a little bit extra protection inside the hull, we're just going to go a little bit extra. Okay, so we got the battery tender plug mounted up here, just waiting for the other side of the connectors to get put on. So I'm going to undo our plug to expose our leads. Now we're just going to match up positive to positive, negative to negative. 5/16 ring on the negative post of the battery. 1/4-inch ring on the negative battery tender. 1/4-inch ring on the breaker. 1/4-inch ring on the battery tender. So 1 5/16 ring, and then the rest are going to be 1/4-inch rings. So This is why it's extremely important to trip our breaker here. Because, watch this. Nothing there, right? Because our breaker's tripped, so we're safe. Definitely a bit of a tight squeeze in here, but we're making it work. All right, so on it, yeah, it's a little bit of a tight squeeze, but thankfully we made it work. So yeah, we're not in bad shape here. We got a few more little tiny things to do, but we are done with the battery section of the build. All right, so one thing I'm gonna do as a little nice trick for wire management is I'm going to take our saddle clamps, which is the same thing that's holding up these guys nice and neatly. I'm gonna take our saddle clamps here, and I'm just going to run them across the top of the kayak so that the heavy 4-gauge wiring is out of the way. And thankfully, with this native hammer, there's like a nice little lip inside the hull. You can perfectly mount these things too, which is awesome. Now I got a few stuck. I'm gonna take our zip ties, start tying them in. All right, so yeah, that wire is tucked up out of the way. Can't even see it if you're looking right down into the bow hatch. You can't even see the wiring, which is what we want. So that's awesome. Now we're just going to do two more small things. We're going to pair the remote, and then we're going to pair the heading sensor, and then that should be it for today's video. All right, so here's the moment of truth. We got the remote out of the box. Let's power this guy on. Hope all goes well. Bingo. All right, this thing is booted up, turns on, means we did something right. So I turned the remote on here. This is the advanced remote from Minn Kota. Just going to peel back the plastic. It says you are responsible for the safe operation of this vessel. I agree. All right, this is powered up. The remote is on. All that's working. Spot lock, got all of our features. Things working good. So now we have to pair our Minn Kota puck for the spot lock jog. So we're going to pair that now. All right, so the first thing we're going to do for our Minn Kota puck is we're going to turn on our S for stern. That turns on the puck. And I do see a bright blue light on the puck over there. So now we're going to press the pair button on the heading sensor. Okay, that's beeping. Now we're going to go over here. I'm going to press that pair button. Hold it. There we go. It is all paired up. As you can see, it was just blinking. It's still blinking. So that goes to show that we are good to go. And that is directly according to our directions here. So watch the heading sensor to be sure that once it successfully pairs, it starts emitting the LED pattern for normal operation. So after the heading sensor is paired with the trolling motor, proceed to sensor calibration and sensor offset. So yeah, it says right in the directions here. The process of calibrating the heading sensor must occur while your boat is on the water. So we cannot do that yet. We will do that later. I'll make sure Carl knows that before the start of the season here. So let's do an outro. All right, everybody. So I wanted to take a quick little tour for you guys. So we got our 24-volt Minn Kota Terrova here. This thing's ready to go. Mounted to a quick release plate. And then our native Watercraft plate for rigidity goes down there to our lower unit. We have our battery tender plug. We did cut the cable here to shorten it a little bit to our battery tender plug. This is an amazing plug. I highly recommend this plug. We'll open this guy up. And then, as you can see, got our 4-gauge going right up the top here. You can't even see it from up here, so you don't lose any part of the hatch. But it's held in by saddle clamps, so no worries there. Goes right back to the battery area. Again, if you want to remove this bucket and just run it straight to the battery, you can do that. But for us, we wanted an extra clean install. So we got our battery tender plug coming up here as well, coming down to our negative terminal. And then our positive breaker terminal, which is a 60 amp ignition protected circuit breaker. Again, non-negotiable safety requirement. If you're not going to install overcurrent protection, don't even bother installing the device. So we have all of our connections here, all nice and tight. And our very short battery jumper here, it's only about 1 inch or 2, which is well within our 7-inch maximum requirement. So that's great. And then over here we have our Minn Kota puck, our heading sensor puck. That is tied into our yak power system on the stern option. And as you can see, it is on and it's flickering. That tells you it's normal operation. So yeah, we are all set. I think this came out fantastic. Let's do a proper outro here. Okay, everybody. So that is going to do it for the install in terms of what I have here in the garage. So this motor will be seeing stow and deploy lines as well. However, we ran into some issues with shipping. So Carl will be handling that on his own to be able to install that. So eventually this motor is going to have stow and deploy lines, but we won't be doing it in this video, unfortunately. So that is it for the install in terms of what we've got today. As you can see, this thing's working flawlessly. No issues. Remote's paired. Heading sensor's paired. The wiring is run safely and efficiently with adequately sized wire. All crimped down with 3-to-1 heat shrink. We have our 60 amp ignition protected circuit breaker back there, so this install is safe. So that is going to do it for the install. I really hope you guys enjoyed this. This was a blast to do. We have one more episode for the main build series episodes on the native hammer, and that's going to be installing some live scope stuff. So we have our Sniper Marine pole here. We have a GPS map Garmin here. We have a full LVS 34 live scope setup to install on this kayak. So this thing is going to be a seriously tournament ready build done professionally, which is the most important thing in my opinion. So yeah, I really hope you guys enjoyed this video and definitely stay tuned. So we'll see you guys next time. Thank you.